Hello everyone, welcome to our lecture on the metric conversions, scientific notation, and significant figures. So this will talk a little bit about the measurements that we use in chemistry and make some connections to all of our measurements that we were making before. We talked about the fact that when I estimate that final digit, what I'm really saying is I only know that much of the measurement. So this is going to build up to being able to correctly report the number of significant figures or the parts of the measurement we actually know in a calculation. To begin, for the metric system, this particular chart is really your go-to tool to help you convert back and forth between the prefixes. Some of the most common ones we'll be using will be milli and kilo, as well as the basic unit. So those would be the ones without the prefixes, like grams, liters, or meters. The prefixes help us give context to the measurement. For example, I wouldn't want to measure my distance to California in millimeters because that would be a really big number. By measuring in kilometers, it's going to make that unit a lot more appropriate and make the measurement a lot easier to work with. So, time for some practice. In your right-hand column, you'll want to follow along with me as we do these examples. So the way it works is I'm going to start with whatever is my given unit, meters. I'm going to find that place on the conversion chart. Next, I'm going to count how many places I move to get to the unit I want to be at. So I'd move 2 to the right in order to go to centimeters from meters. That means my number's going to get bigger and my decimal point moves to the right because metric is all base 10. So when I move the decimal place 2 to the right, I see that I have 25,600 centimeters. Now for the next one, I'm going to go from centimeters to millimeters. That's only one decimal place to the right. So that would make this number 972.5. This time, as we move to the right, I'm going from liters to milliliters. That's going to be 3 places. So when I move 3 to the right, I'm going to get 574. All right, the next one, the first time we're going to go to the left. So I'm going to start at milligrams, and I'm going to move to grams. That's 3. So 3 places to the left would give us 0.00852 grams. Grams to kilograms. Again, I'm moving to the left. 3 this time again. And our last one, moving from centimeters to hectometers. It's going to be 4 places to the left. So pretty much what you need to be able to do is to understand the order of the prefixes and move back and forth between the units you want and the units that you have. Now that we know how to convert between units, sometimes our numbers get really big or really small. So we can use something called scientific notation to help represent those numbers more easily. The reason we do it in multiples of 10 is that when we are working with these numbers, we can simply move the decimal around by multiplying or dividing. So if I have 5,000 and I want to convert that to scientific notation, I'm going to move the decimal so that there is a single number, one non-zero digit, left of the decimal. I then use an exponent on the 10 to tell me how many times I move the decimal. If the exponent is positive, that means the number is bigger than 1, which 5,000 is definitely bigger than 1. In a decimal, I know I'm going to have to move the decimal place to the right to get that single non-zero digit left of the decimal. Now, while I moved it 3 times as well, you'll notice that the decimal is less than 1, so we use a negative exponent to show that it's a small number. Now, in the space on your note sheet, I would like you to draw out this grid. We're going to talk about an explanation of scientific notation. We have some sample conversions. We'll go through some examples and some non-examples. So the whole point of scientific notation is to report numbers larger than 1,000 or less than 0.001. It's going to mean that there's 1 digit in the ones place times the power of 10. So for that beginning number, think of it as a number that is equal to 1 up to less than 10. That's our range. So you're going to have a single digit number before the decimal place. In our examples, we see that in every one, there's a single number left of the decimal, and we have some number times 10 to the something. That is our format for scientific notation. In our non-examples, these first two, they have too many digits left of the decimal, so they're bigger than 10. They don't work. Here, these numbers are less than 1. They also do not work, so that number in front of the decimal should be a non-zero number. The problem with 4.6 times 10 to the times 12 to the third is that it's not a base 10 number. So the issue here, I have to have times 10 to the something, not any other number. So if we take a look at the top, we'll do some conversions here. Remember, big numbers, positive exponents, little numbers, negative exponents. In each case, I moved the decimal, so I had that single non-zero digit left of the decimal place, and the exponent becomes how many times I move the decimal. So, take a moment to try these conversions in the right-hand column below there for yourself. In a little bit, I will give you the answers. When converting back to the original numbers, you just have to move the decimal to make sure that you get a bigger number or a smaller number. All right, moving on, significant figures. So now that we know our metric conversions and we can report numbers correctly in scientific notation, we are going to talk about those numbers we report from our measurements. Remember that we said our estimated last digit is the last part of a measurement that we actually know. So the first sentence fills in your middle column, and the second sentence fills in your right-hand column. What I'm going to do is finish with this part of the video, so this will be the end of part 1, and the back side of the sheet will be a separate video that you can look for that goes through the rules specifically, as well as rules for adding, subtracting, multiplying, and dividing. So quick break. Then take a look at the back side of the sheet to start video 2.